Assalamualaikum. Hi guys. In this video, we are going to cover for the second factors affecting the atomic radius, which is shielding effect. Shielding effect depends on the value for principal quantum number. This is only for valence electron, where we know that another name for shielding effect is screening effect. So how screening effect happen in an atom? Shielding effect caused by mutual repulsion between electrons of inner shell and electrons in the valence shell. If you see from this picture, you got nucleus in the middle, and what you can see that the electrons in the first shell here, n equals to 1, and this is electrons in the n equals to 2. We got 3 electrons in the inner shell and 2 electrons in outer shells, valence shell. So what will happen? Electrons, they got negative charge. So between the same charge, there will be repulsion, daya tolakan. So that is why we use a new term here, mutual repulsion. So mutual repulsion only happen for electron. And in this case, between electrons in the inner shell, n equals to 1, with electrons in the valence shell, n equals to 2. So daya tolakan ini akan menghasilkan shielding effect, where inner electrons will shield the valence electron from getting closer to the nucleus. That is why shielding effect happen. Shielding effect also occurs between electrons in the same shell. Contoh, you can see 3 electrons in the first shell, there will be shielding effect as well. Same goes for the electrons in the second shell, our valence shell. However, it is not very significant. That's why we don't discuss more about that. We only discuss the electrons in the different shell, inner shell and valence shell. Let's go one example how the shielding effect occurs between two different atoms. What I have here is sodium and potassium. You can see that for sodium, the electronic configuration is 1s2, 2s2, 2p6, 3s1. And for potassium, you got 19 proton numbers, so 19 electrons, just like this one. So you can see that the highest n value for sodium, which will be n equals to 3. And for K, potassium, the highest n value is n equals to 4. So we can determine that the electrons in 1s, 2s and 2p orbital here, or electrons in 1s, 2s, 2p, 3s and 3p here, will be the inner shell electrons. So now, how you want to describe about shielding effect based on sodium and potassium here? First, you say that sodium and potassium are located in the same group. You can see that they have the same value for number of valence electron, 1, so they are in group 1. But the shielding effect for both of them are different, because the shielding effect for the valence electron in sodium is less than K, because sodium has smaller n value compared to potassium. So that's why sodium will experience less shielding effect compared to K. Therefore, we can conclude that the variation when n increases, shielding effect increases, because electrons di dalam inner shell akan shield, akan menghalang valence electron daripada dekat kepada nukleus. Sekiranya banyak inner shell, maknanya jauhlah jarak valence electron to get closer to the nucleus. Sama macam case potassium here. So I hope you are clear how to describe shielding effect between different atoms. That's it for this video. I will see you in the next one. Bye!